In this question, we have to evaluate your determinant D1, which is the order of 2 cross 2. And to obtain this determinant, we have to cross multiply. This minus 1 multiplied with 2 will give us minus 2 minus 5 into 4 will give us minus 20. So this minus minus become plus, and we just have to take 20 minus 2, which will give us 80. Here's your final answer. Ta-da! Now let's try to evaluate your determinant D2, which is order of 2 cross 2. And to evaluate this determinant, we have to cross multiply. This cos theta multiplied with cos theta will give us cos square theta minus sin theta will multiply with minus sin theta will give us minus sin square theta. So here we'll get cos square minus minus become plus sin square theta, which is equal to 1. Ta-da! And without wasting time, evaluate this determinant D3, which is order of 2 cross 2. And to obtain this, we have to cross multiply. This x plus 1 multiply with x square minus x plus 1. So we'll get x plus 1 into x square minus x plus 1 minus x plus 1 multiply with x minus 1 will give us x plus 1 into x minus 1. Now, in first term, we have a plus b into a square minus ab plus b square, which is equal to a cube plus b cube. So your first term can be simplified as x cube plus 1 cube. And in second term, we have a plus b and a minus b, which is equal to a square minus b square. So we will get x square minus 1 square. So here we get x cube minus x square, and 1 minus minus 1 will become plus 1. So get plus 2 as your final answer. Ta-da! In this question, we have one matrix A and we have to show that determinant of 2A is 4 times determinant of A. So first of all, let's try to get your right hand side, which is determinant of A. Now, just expand it. We just have to multiply this 2 with 1 will give us 2 minus 4 multiplied with 2 will give us 8. So your determinant of A will be 2 minus 8, or we can say minus 6. Therefore, 4 times determinant of A is nothing but minus 24. And to get your right hand side, we are going to need 2A. That means we have to multiply 2 with each element of the matrix A. So, from first row, we will get 2, 4. And from second row, we will get 8, 4. So, we can say determinant of 2A will be determinant of 2, 4, 8, 4. And let's cross multiply. 4 2s are 8 minus 8 4s are 32. So we will get determinant of 2A is equal to minus 24, which is exactly equal to the 4A. So hence proved determinant of 2A is 4 times determinant of A. Ta-da! In this question, we have one matrix A and we have to show that determinant of 3A is equal to 27 times determinant of A. So, let's try to get determinant of A first. Now let's expand our determinant with respect to first row. So we have to write down their elements and multiply with cofactors. So your first element is 1. Then minus your second element, which is 0. And finally plus last element, which is 1. Now we have to fill this determinants of 2 cross 2. So let's try to get minor of first element by ignoring its row, which is first row, and its first column. So remaining terms will create the minor of first element. Now let's get the minor of second element, which is in first row and second column. So let's collect the remaining term. Its first column will be 0, 0 and its second column will be 2, 4. And finally get the minor of last element, which is in first row and first column. So ignore them and you will get its minor. Place it over here. Now we get 2 cross 2 matrix, and to expand them you have to cross multiply. This 4 multiplied with 1 will give us 4 minus 0 into 2 will be 0. Then minus 0 into anything will be 0. But let's expand. 4 zeros are 0 minus 0 twos are 0 again. Plus 1 into 0 zeros are 0 minus 0 into 1 will be 0 again. So here we'll get 1 into 4, or we can say 4, and rest of the terms are 0. So we get our determinant of A. So we can say 27 times determinant of A is nothing but 108. Now let's try to get our left hand side, which need 3A. So we have to multiply 3 with the each element of matrix A. Multiply 3 with the first row will give us 303. Then multiply with the second row will give us 036. And from the last row we will get 0012. So we can say determinant of 3A will be determinant, and let's get their elements. So we have 3 cross 3 determinant. Let's expand with respect to first row. So we have to write down their elements and multiply with their minors. The first element is 3, then space for the minor, and minus second element, which is 0, plus last element, which is 3. Now let's fill these determinants. Your first determinant can be obtained by ignoring first row and first column. So you will get your 36012. Now let's get the second determinant, which is within the multiplication of 0. So ignore its row, which is first row, and its column, which is second column. So here we get the first column of determinant, and here we get the second column of determinant. Similarly, your last determinant, which is within the multiplication of 3, can be obtained by ignoring its row and its column. So we get your required determinant. Now in further simplification, we have to expand these 2 cross 2 determinants. Your first determinant can be obtained by 12 into 3 will give us 36, minus 0 into 6 will give us 0. Then in second element we have 0, so we don't have to worry about this second determinant. 12 zeros are 0 minus 0 6 are 0, and in last determinant we will get 0 into 0 will be 0 minus 0 into 3 will be 0 again. So here we get 36 into 3 will give us 108, and rest of the terms are 0. So we get determinant of 3A, which is equal to 108, and 27 times determinant of A is also 108. So we can say determinant of 3A is 27 times determinant of A. Hence proved. Now, if we talk about some shortcuts, you should consider that your determinant of A is a upper triangular matrix, and its determinant can be easily found by multiplying its principal diagonal elements. So we just have to multiply this 1 into 1 and 4. So you will get 4, which we get in example. Use this shortcut for quicker result. So ta-da! In this question, we have to evaluate this determinant. So let's expand with respect to first row. So we have to write down the elements of first row and multiply with its cofactors. So the first element is 3 minus the second element is minus 1 plus the last element is minus 2. Now let's obtain minor of first element by ignoring first row and first column. So we will get 0 minus 1 minus 5 0. Then obtain minor of minus 1 by ignoring its row and its second column. So the first column will be 0 3 and second column will be minus 1 0. And your last minor can be obtained by ignoring first row and last column. So we will get 0 0 and 3 minus 5. Now in further simplification, your 3 will be as it is and open the determinant. 0 zeros are 0 minus 5 minus 1s are 5. Then minus minus become plus 1 into 0 zeros are 0 minus 3 minus 1s are minus 3. And in last term, we will get minus 2 into minus 5 into 0 will be 0 minus 3 into 0 will be 0 again. So here 3 minus 5s are minus 15, minus minus become plus, so we'll get plus 3 and minus 2 into 0 will be 0. So your determinant will be minus 12. Ta-da! We have to evaluate this determinant. So let's expand our determinant with respect to first row. So let's write down the elements of first row and multiply with its cofactor. So your first element is 3 minus the second element, which is minus 4, plus the last element is 5. Now let's find out minor. The minor of first element can be obtained by ignoring its first row and first column. So here we'll get 1 minus 2, 3 1. Then the minor of next element can be obtained by ignoring its first row and its second column. So the first column will be 1 2 and second column will be minus 2 1. Now your last minor, which can be obtained by ignoring first row and last column. So we will get 1 1 and 2 3. Now let's simplify. Your first element 3 will be as it is. Let's get the value of first determinant. By multiplying 1 with 1 will give us 1 minus 3 minus 2 is a minus 6. In second element, minus minus become plus 4 and cross multiply. 1 1s are 1 minus 2 minus 2 is a minus 4. So it will become plus 4 plus 5. 3 1s are 3 minus 2 1s are 2. So here we'll get 3 into 7 plus 4 into 5 plus 5 into 1. Or we can say we will get 21 plus 20 plus 5 will give us 46 as a final answer. Ta-da! Let's evaluate this determinant. Let's try to expand with respect to first row. So we have to write down its elements and multiply with its cofactors. So your first element is 0 and the space for its cofactor minus the second element is 1 plus the last element will be 2. For first element, we have to ignore its first row and its first column. So we will get 0 minus 3, 3, 0. Then the minor of 1 can be obtained by ignoring its row and its column. So the first column will be minus 1, minus 2 and the second column will be minus 3, 0 and the last one will be obtained by ignoring first row and last column. So we will get minus 1, 0, minus 2, 3. Now let's cross multiply. 0 into anything will be 0, minus 1 into 0 minus 1 will be 0, minus 2 into minus 3 will be 6, plus 2 into 3 minus 1 are minus 3, minus 2 into 0 will be 0. So first term will be 0, minus become plus and will give us plus 6. And in second term, 2 into minus 3 will give us minus 6. So your determinant will be 0. So from this example, we can remember one property of determinant. Always remember the odd order of skew symmetric determinant will always 0. Ta-da! In this question, we have to evaluate this determinant. So let's expand our determinant with respect to first row. So you have to write down their elements and multiply with minors. So your first element is 2, multiply with its 2 cross 2 minor, then minus second element which is minus 1 and plus your last element which is minus 2. Now let's obtain minor of your first element by ignoring its first row and first column. So here we'll get 2 minus 1 minus 5, 0. Then minor of second element will be obtained by ignoring its first row and its second column. So first column will be 0, 3 and second column will be minus 1, 0. And the minor of last element can be obtained by ignoring first row and third column. So we will get 0, 2, 3 minus 5. Now let's simplify. Your 2 will be as it is. Let's open the first matrix. 0 multiplied with 2 will give us 0 minus 5 multiplied with minus 1 will give us 5. Here minus become plus. So we'll get plus 1. Then 0 zeros are 0 minus 3 minus 1s are minus 3. And here we'll get minus 2 into minus 5 into 0 will give us 0 minus 3 2s are 6. So your first term will be minus 10. In second term, minus become plus. So we will get plus 3. And finally, minus 2 and minus 6 will give us plus 12. So here we'll get 5 as your answer. Ta-da! In this question, we have matrix A and we have to find determinant of A. So we have 3 cross 3 determinant. So let's expand our determinant with respect to first row. So we have to write down the elements of first row with their minors. the first element is 1 with 2 cross 2 matrix minus the second element of the first row is again 1, and finally plus the last element is minus 2. Now it's time to fill the 2 cross 2 determinants. So let's fill your first determinant, which should be the minor of first element. So we have to ignore its first row and first column. So your determinant will be 1 minus 3, 4 minus 9. Now to obtain minor of second element, we have to ignore first row and second column. So we have to select this 2, 5 as your first column and minus 3 minus 9 as your second column. And for the last element, we have to ignore first row and last column. So we have our required determinant. Now let's simplify. 1 will be as it is. Let's solve your first determinant by cross multiplying. Minus 9 ones are minus 9 minus 4 threes are minus 12. Then your second element will be as it is. Minus 9 twos are minus 18 minus 5 threes are minus 15. And here we'll get minus 2 and cross multiply. 4 twos are 8 minus 5 ones are 5. So 1 will be as it is. In first bracket, minus minus become plus. So we'll get 12 minus 9, or we can say 3. Minus 1 again as it is. In second bracket, minus minus become plus. 15 minus 18 will be minus 3. And minus 2 will be as it is. Here 8 minus 5 will be 3. So here we'll get plus 3 and minus 6, or we can say your determinant A will be 0. Ta-da! In this question, you have to find value of x. We have a determinant equation. So let's solve left determinant. First of all, you have to multiply 1 with 2, which gives 2 minus 5 fours are 20. Now on right hand side, x multiplied with 2x will give us 2x square minus 6 fours are 24. Now let's simplify. 2 minus 20 will become minus 80 is equal to 2x square minus 24. So here we will get 2x square is equal to minus 18 plus 24, which will give us 6 is equal to 2x square, or we can say your x will be plus or minus root 3. Ta-da! In this question, you have to find the value of x. So let's simplify our left hand side. 5 2s are 10 minus 4 3s are 12. And on the right hand side, you have to multiply 5 with x will give us 5x minus 2x 3s are 6x. So on left hand side, 10 minus 12 will give us minus 2, and 5x minus 6x will give us minus x, or we can say the value of x is 2. Ta-da! Here we have one determinant matrix and we have to find the value of x. On left hand side we have x to 18x. On the right hand side we have 6 to 18 6. So to get the value of x, let's simplify our determinant. Your x will multiply with x will give us x square minus 18 2s are 36. And on right hand side 6 6 are 36 minus 18 2s are 36. So here 36 will cancel out and we will get x square is equal to 36, which will give us x is equal to plus or minus 6, which is given in option D. Ta-da!